Okay, so in this problem set, you basically have to show how you would go from reactant to product using more than one step if necessary, show a reaction pathway. So no mechanisms needed, just basically go from here to here. So there's a couple of different ways you can do this. So let's think through this. The best strategy is see the product that's formed and think about, well, how could we go back from the product to the reactant? Okay, so let's trace the steps back. So let's do like a little bit of a retrosynthetic uh, sequence. So I'm just going to go ahead and look at this product and go ahead and say, well, this alcohol could have come from an epoxide. Okay, so if I had an epoxide out here like this, okay, and I had a Grignard reagent, so let's say I had PHMgBr as the Grignard reagent, then the forward reaction would mean the Grignard reagent would stack this carbon and pump that bond up to the oxygen, okay? So that's the strategy we can take. And of course, you can do this different ways, but that's the way we'll go ahead. That seems to be the cleanest approach, okay? So now, the question though is, how do you make this Grignard reagent? And for that, you can have to start from benzene. So let's go ahead and begin our synthesis. So if I start with benzene, I'm just going to go ahead and brominate benzene first. So I'll do Br2 and Fe. That gives me Br. Then I'll add magnesium with dry ether. And there's my Grignard reagent. Then I'm just going to react it with this epoxide. Okay, and that will give me, I'm just going to write this as pH O minus this, and that O has got an Mg plus with a Br. And then to get the product, it's just going to be H3O plus at this step, and I get the product. All right. Okay. The next one, in number B, I basically have to go from this to this, and notice carefully out here the stereochemistry is E. Okay. So when the stereochemistry is E, I have to think about, well, how do I go from this one to this one? So maybe one option out here is to think back again. Well, that double bond with the stereochemistry E should actually remind you of something called the Birch reduction. That's in your organic 1 notes. Birch reduction. And a Birch reduction takes a triple bond and makes it into a double bond, which is trans. Okay. So let's go ahead and go back. And because I don't have much space out here, I'm going to do this. I'm going to do pH C triple bond C pH. Okay. Now the question is, well, how am I going to make this from this? Okay. So let's see. So if I start with benzene, I got to think about this for a second. Give me a brief minute. And I think I'm going to run out of space out here. So let me go ahead and add a page after the sheet, and let's think about it on this page. So I'm going to go ahead and rewrite the compound pH C triple bond C pH. Okay, so I basically need 2 benzenes connected. So what if I had a benzene this way that reacted with another benzene with 2 carbons, but let's say I made 1 carbon a C double bond O, put a Cl out here, and then put a CH2 out there, and follow that up with another benzene ring. Then I could think of reacting these two together via Friedel-Crafts acylation. So if I do that, I'm going to get PHC double bond O, CH2PH. Okay, so AlCl3. That's all I need for the acylation. AlCl3. Okay, so I get that. Now I can go ahead and change that. I'm going to go ahead and reduce the C double bond O to an alcohol. So I can just do a sodium borohydride, NaBH4, with ethanol. Step 1. Step 2 is H3O plus. And that's going to give me PHCHOH, CH2PH. And now I'm gonna dehydrate this. So if I dehydrate this, I can just use like a strong acid, concentrated H2SO4. And then that's going to give me PHCH double bond CHPH. Okay. At this point in time, to get that specific stereochemistry I was talking about, I'm going to go ahead and add bromine. And then what that's going to do is that's going to put a bromine out here and put another bromine out here. And then I'm going to add a strong base, KOH. You could use something like NaNH2 as well, but KOH should work. And what that does is it'll do an E2 elimination and remove this hydrogen and that bromine and this hydrogen and that bromine, leaving behind PHC triple bond C, PH. And then you do the Birch reduction, which is LiNH3 liquid. And that gives you C double bond C, pH. One hydrogen is up, one hydrogen is down, one hydrogen is down, one hydrogen is up, and there you have it, E. Okay, so this problem actually required you to think a lot about your organic 1 reagents. Okay, so that being said, let's take a look at the next problem on the list. Here you have an aldehyde, and you actually have now, this problem is very interesting. You have a symmetrical alcohol. See how you have 2 OHs, and then this piece is similar to this piece. So the simplest way I would recommend you do it is think of a Grignard reagent. So this piece comes in out here. So all you need is 2 Grignard reagents. So you can do 2 PHMGBr, okay? And what that'll do is, I'll just show you the mechanism for one of them. PHMGBr. Well, I can show it to you for 2 of them, but then it'll get too cluttered. But basically that's what happens. And the same thing happens, I'll just tell you what happens out here. The same thing happens out here. And that gives you something that looks like this. O minus, pH, O minus, pH. Okay? And then you just do an H3O plus, and that protonates the O minuses, generating the alcohol. Nothing too complicated out there. Excuse me. Take a look at the next one. The next one actually is a little more long, so I'll move this one to the next page. So it's going to be, I might have to go back and forth a little bit to get to the next page, but bear with me. So that's D, and we are trying to start with this, and we're trying to make, you're putting a double bond on top. Okay. Okay, so we very strategically put a double bond out here. Okay, so whenever you have something like this where you have a double bond out here, And notice carefully, you have nothing out here. Okay. So the way you want to think about this is you want to think that, okay, at this position, if there's a double bond out here, a good retrosynthetic strategy is to cleave that double bond. And if you think backwards, where the double bond is, you put a C double bond O, and the other piece, this piece out here with the ring, that becomes a Grignard reagent. Okay, so again, don't forget there's an extra carbon, there's a carbon out there, so that Grignard reagent is basically PHCH2 MgBr. Okay, all right. Now the question is, how do you make this from this? Okay, and actually you can go backwards from here. Okay, just to kind of think about strategy, but you could, this one doesn't really need to go back too far. Actually, let's just go back and show you. So I'll go back one more step. So you want to change that aldehyde into an alcohol, because I'm thinking in my head, I'm thinking I want to get to a halogen out there. That's what I'm trying to do. Okay. Halogen. And now we're just one step away from this. So let's do the synthesis. So the synthesis, you can use something like NBS for this one. NBS CCl4 in the presence of light. And what it does is it puts a bromine at an allylic position. That position, this carbon is an allylic carbon. So it puts a bromine out there. Then I'm going to displace that bromine and I'm going to put an OH out there. Okay, so you could just do something as simple as add just water, and what it'll do is that bromine is going to leave because it's going to generate a pretty stable carbocation because it's an allylic carbocation, and then water will attack. Again, we don't need the mechanism out here, but it's good to think in terms of the mechanism to understand how that happens. So now that you have an OH out there, you can oxidize that OH. So PCC is your friend out here. And there you have your ketone. Once you have that ketone, now you're going to use your Grignard. Okay. So go ahead and react that with your Grignard, PHCH2MgBr. And this thing comes here, kicks that out, up. O minus, CH2, oops, CH2PH. Okay. And then you do the H3O plus. And that gives you OH out here, CH2PH. And then you're going to dehydrate this, okay? So the dehydration is simply going to be something like a, excuse me, you can do a concentrated H2SO4, okay? So concentrated H2SO4, and that's going to basically pump that OH off and put a double bond out there, okay? And that's basically what you're trying to make. All right, the next question, so the last one in the series is E, where you're trying to go from here to here, okay? And there is actually enough space out here, so we can think about this out here itself. The key thing to note is, notice carefully, there's two groups out here that are identical at this. That means, and also notice that's a tertiary alcohol. So that's a 3-degree alcohol with two identical groups. Anytime you see a 3-degree alcohol with two identical groups, that means you're using a Grignard reagent with one of these groups as in the Grignard reagent that's attacking an ester. So if you look at this, that's a cyclic ester. It's a lactone. So all you have to do is take a Grignard reagent with a CH3-MgBr and attack this ester. And I'll kind of, in this one, I'll show you the mechanism. Although if I ask you for this to do this on a test, you don't need to show me the mechanism unless I specifically ask you for it. But I'm showing you the mechanism so you can understand how this formed. So we take the CH3 that attacks here, that goes up there. That's step one. I'm going to put the CH3 out there. Then, so that's MgBr. No, you don't have to write the MgBr, so I'll just take that off, make it clean. That comes down and that leaves. So you basically have a ketone right now. Okay, on this side of the molecule. Then another Grignard attacks, CH3-MgBr. So basically you need two equivalents. That attacks, that goes up, and you have CH3, CH3, and there you have it. Now when you do an H3O plus, both the O minuses get protonated, giving you this molecule. Okay? All right.